In this video tutorial, we will take a look at the Synthesizer Tool. The Synthesizer Tool helps predict the performance of sandwich panels, cellular structures, composites, as well as other hybrid materials, and to compare those with standard materials. The tool also includes a part cost estimator, which is explained in another video tutorial. Note that this video builds on previous video tutorials about creating charts and custom subsets. When we open CES EduPack, we are presented with the Databases window, where we can select the most appropriate database for our project. The Synthesizer tool is available in several advanced databases: Aerospace, Bioengineering, Eco-Design, Polymer, and Sustainability. Here we will use Level 3 Eco-Design. To open the Synthesizer tool, let's click on the synthesizer icon in the main toolbar here. The tool opens in a new window, showing the available models grouped in 6 different sections. As an example, we will investigate the properties of an aluminum face PVC core sandwich panel over a range of geometries. To do so, we will select Balanced in Sandwich Panels, and a new window appears. We first have to enter the materials for each component. A material can be selected by clicking the Browse button here. For the face sheets, we can select a wrought aluminum alloy in the 7075 T6 condition to give a stiff, strong face. Now, for the core material, we can choose a foam made from PVC to decrease the overall weight of the panel. Next, we need to enter some geometric parameters. We can choose a range of face sheet thicknesses here, between 0.1 and 3 mm, and use, for example, 3 values in this range. For the core, we can have thicknesses between 10 and 50 mm and use 5 values. Now we need to select a loading condition from the drop-down menu here. We can choose a simply supported and centrally loaded beam and a span length by entering a value here. We'll leave it at the default 10 meters. Finally, we need to enter material names for the record labels. We can call the face sheet aluminum and the core PVC. The tool is showing here that this combination will generate 15 records. Click Create. The tool has now generated our panel records, and so to finish and view them, press Finish. The records generated by the tool are now placed in the folder called My Records, which we can see by opening Browse and looking at the material tree. Let's now open a record. Here you can see the range of property values calculated for the panel. The geometry and loading is shown at the top of the record here. The general properties of overall price and density are shown here. The relevant mechanical properties are calculated and the expected failure mechanism is given. Here, face sheet yielding. Thermal, electrical, and eco properties are shown here. And the yellow box at the bottom of the record lists the parameters of the model and gives some additional calculated properties. We can now use the Chart Select button to plot a chart and visually compare the properties of the new records we have just generated to those of the bulk materials in the database. We can also plot a chart using only the materials we're interested in with a custom subset. We'll create a subset only including our face sheet material, which was aluminum 7075 in the T6 condition, the core material, which was PVC, and the generated records in My Records here. Now let's plot the chart, flexural modulus against density. We can see that our synthesized material has properties in between the 2 constituent materials. In the following video tutorials, we can learn about the other advanced databases and tools that are available in CES EduPack.